So, hi all, welcome to today's video. So today, let's explore some real-world scenarios where perfect forwarding is commonly applied. Understanding these common scenarios will highlight the practical significance of perfect forwarding in C++ development. So before jumping onto the video, I would like to request everyone to subscribe to this particular channel so that you will not miss any updates from this channel. So continuing with our video. So first application where you will find the use of perfect forwarding is in the case of smart pointers. So in the case of smart pointers, perfect forwarding is often used. So functions that construct and manage smart pointers benefit from perfect forwarding to handle various types of objects seamlessly. As you can see in this make unique API, the template argument is being used here with a universal reference operator so that it can handle different types of value. Maybe it might be an R value or it can handle L value as well in the same way so that it can be forwarded to the correct make unique version of handling that particular value. So this is kind of you can treat it as a code snippet. It may not be the exact replica of how it might be actually implemented. So you can be an approximate version of it. So the one of the practical case is smart pointers. And the second use case is in the case of the generic containers. So perfect forwarding is crucial when designing generic containers that can hold elements of different types. So containers like STD vector or custom implementation can use perfect forwarding to efficiently manage and store elements. So the implementation of this container needs to be generic so that it can store any kind of data. So here you can see that I am trying to fill elements or trying to store in this particular generic container called vector. So how I am doing is I'm creating a template function called emplace. So I'm using the perfect forwarding or the universal reference operator here so that it can accept either L value or R value. It can be passed to this emplace function and can be correctly forwarded to the corresponding version of emplace back API. So here you can see the application of what is known as perfect forwarding. So this particular three dots you see, this kind of a variadic argument or variadic templates is being used here to handle an array of arguments. So jumping on to the next use case is a custom allocator one. So custom allocator in scenarios involving custom allocators, perfect forwarding is employed to pass arguments to allocator functions with the correct value category, ensuring efficient memory management so that the unnecessary creation of memory will not happen or unnecessary copy operation will not happen if you use the perfect forwarding in a correct manner. So in this particular custom allocator, there is an allocate and construct API which uses this universal reference operator and does the perfect forwarding. And there might be some custom allocator logic which might be written here, which uses the forward API to forward to the corresponding overloaded version of that allocate and construct API. So this is a kind of a use case where you will find the perfect forwarding being applied. So the next use case is in the case of a callback system. So callback systems such as the event handler or the callback registration mechanism can leverage the perfect forwarding to allow users to register callbacks with different argument types without the unnecessary overhead. So I don't have a practical example of it. So here, the callback system, when you try to register an event, etc., normally you try to wrap it inside the constructor of that event. Otherwise, you can directly register using the plus equal to, and you can register with directly the event handler. So there are various ways it can accept a different value, different event handlers. Means it can directly accept an event handler, or it can accept an event object which is wrapping that event handler. So if that kind of a scenario comes, then this perfect forwarding comes in because it has to handle different kinds of value types. So that's it I want to cover in this particular video. So thanks.